Welcome to the HasMotion YouTube channel. This video will describe how to implement the plug and gate upper extremity model tutorial as implemented in Vicon using Visual 3D. The upper body model we build will consist of 8 segments, including the thorax, head, left and right upper arms, left and right forearms, and left and right hands. This tutorial does not describe the pelvis definition, but that can be found in the lower body tutorial that's located later in this playlist. Details about implementing the clavicle segment are also provided in the clavicle tutorial on the wiki. The plug and gate full body model consists of the plug and gate upper extremity model as well as the plug and gate lower limb model. Complete the lower body tutorial that is found later on this playlist to complete the lower extremity segments and produce the entire model. We'll try to follow Vicon's definitions as closely as possible, but some modifications are required to implement the model in Visual 3D. This means that the results from Vicon and Visual 3D may show some small differences. Some of the bigger differences are described throughout this video. Vicon defines the origin of segments at the distal end of the segment, while Visual 3D uses the proximal end. This tutorial will use the Visual 3D definition. Complete this tutorial using the plug and gate marker set found on the wiki. It will be easiest if you use the same naming convention. Please note that this is a minimal marker set, so if there is target dropout or a target was not placed, you will likely not be able to use the marker set. This model is also very sensitive to subject's posture during the static trial. When using this model, you should make sure that the subject is in a T-pose during the static trial. We'll start building our model by defining important subject metrics. In addition to subject height and mass, there are 4 required bilateral anthropometric measurements that need to be measured on the subject, including shoulder offset, elbow width, wrist width, and hand thickness. We'll start defining our segments by creating important model metrics like height, weight, and joint radii. Click the Subject Data/Metrics button, select the mass, and select Modify Selected Item. Change the value to 75. Next, select the height value and change the value to 1.8. Now we'll add a new item named Marker Radius and set the value for that to 0.005 meters. Now we'll add another value named L shoulder radius and define the expression as 0.17 times the distance between the left shoulder and the right shoulder, minus marker radius. Also make sure to create the right shoulder radius and define it the same way. Next, create a left elbow radius and set the value to 0.06. Do the same for the right elbow. Next, we'll create a value for the left wrist radius and define it as 0.5 times the distance between the 2 left wrist markers minus the marker radius. Mirror this value for the right wrist using the right wrist markers. Finally, we'll create a value for the left hand offset and set it to 0.03. Do the same for the right hand offset. You can now see on the left the full list of subject metrics that are required to define the model. Now we can start creating the landmark and segment definitions that we need to create our model. First, we'll start with 3 landmarks for the head segment. Navigate to the Landmarks tab and add new landmark. Create a new landmark named head_front. We'll define this landmark using a starting point at the right forehead marker and ending at the left forehead marker. We'll also use an axial offset of 0.5, check the offset by percent 1.0 button, and check calibration only landmark. You can now click Apply, Build Model, and close tab. Next, we'll create a new landmark named head_back. This landmark will be defined as a starting point at the right back of the head marker and ending at the left back of the head marker. Again, we'll use an axial offset of 0.5 and check the offset by percent 1.0 button as well as the calibration only landmark. Once you're done with this, you can apply and build the model and close the tab. Our third head landmark will be the head_mid landmark. This landmark will be defined using a starting point at head front and an ending point at head back. Again, we'll use an axial offset of 0.5, check offset by percent, and check calibration only landmark. This creates a landmark at the middle position between the head front and head back landmarks that we just created. Our final head landmark will be head_right. This landmark will be defined as using a starting point at right forehead and an ending point at the right back of the head. Again, we'll use an axial offset of 0.5, offset by percent 1.0, and make it a calibration only landmark. Now that we've created all of our head landmarks, we can move over to the Segments tab and create the head segment. Enter head in the segment name box and click Create. Define the proximal and distal joint centers as head front and head mid respectively. Next, define the proximal joint radius as 0.5 times the distance between the right forehead and the left forehead. Define the distal joint radius as 0.5 times the distance between the right back of the head and the left back of the head. Add an extra target at the medial location as head_right and choose tracking targets left back of the head, left forehead, right back of the head, and right forehead. You can now click Build Model and close tab to view the segment on your model. You may notice at first that it looks a little off. We'll have to modify the segment coordinate system and the scale to make sure it looks correct. Navigate to Segment Properties and select Modify Segment Coordinate System. Change the anterior-posterior axis to +Z and the distal to proximal axis to +Y. Next, change the model file to head_C7_top. This will apply the proper model file to the segment. Finally, we'll click Rotate/Scale the graphic model. We'll rotate it by 90 degrees vertically, 180 degrees clockwise, move it back by 55, move it up by 40, and scale it by 200 in each direction. Now we can move on to creating the 3 necessary landmarks to define the trunk segment. Create a new landmark named thorax_prox. This landmark will start at the clavicle and end at C7. We'll use an offset again of 0.5 in the axial direction, offset by percent 1.0, and click Calibration Only Landmark. Next, we'll create the distal thorax landmark named thorax_dist. This landmark will start at the sternum marker, end at T10, and again use an axial offset of 0.5, offset by percent 1.0, and be a calibration only landmark. Our final trunk landmark will be the anterior-posterior thorax landmark. This landmark will be named thorax_AP and go from the starting point at the clavicle to the ending point at the sternum. Again, we'll use an axial offset of 0.5, check offset by percent 1.0, and check calibration only landmark. Now we can move on to creating the trunk segment definition. Navigate to the Segments tab and enter thorax/ab in the segment name box. Click on Create Segment. In the thorax/ab tab, we'll enter thorax_prox as the joint center and 0.5 times the distance between the right shoulder and the left shoulder as the proximal joint radius. Next, we'll define the distal joint center as thorax_distal and again use 0.5 times the distance between the right shoulder and the left shoulder. We'll add an extra target at the anterior location using thorax_AP. Finally, we'll select tracking targets as C7, clavicle, sternum, and T10 at a depth of 0.5 times the distance between C7 and clav. Click on Build Model and close tab before proceeding. Again, you'll notice that the segment does not look quite right. We'll have to change the graphic and rotate scale the graphic model to make it look more correct. Go to the Segment Properties tab and change the model file to the one shown on the screen. Next, we'll scale the model and change the scale height, scale width, and scale depth all to 120. Now that our thorax segment looks a little more correct, we can move on to creating the landmarks for the upper arm. Navigate to the Landmarks tab and create a new landmark named LSJC, or Left Shoulder Joint Center. This landmark will start at the left shoulder and be defined by an existing segment being the thorax/ab. We'll use an axial offset of -1 times the left shoulder radius plus the marker radius and check calibration only landmark. Make sure to copy and reflect this landmark to create the right shoulder joint center. Next, create a new landmark for the left wrist joint center. We'll call this landmark LWJC, and it'll start from the LWRA and end at the LWRB. We'll use an axial offset of 0.5 and check offset by percent 1.0. Again, you'll want to copy and reflect this landmark to create the right wrist joint center. Our final arm landmark will be the left elbow joint center. We'll name this LEJC, and it'll start from the left elbow and end at the left shoulder joint center with a lateral object at the left wrist joint center. We'll use a medial lateral offset of -1 times the left elbow radius plus the marker radius and check calibration only landmark. Once you've successfully defined the left elbow joint center, copy and reflect it for the right elbow joint center. Now that we've defined all of the landmarks for our upper arm, we can move on to creating the segment. In the Segments tab, select Left Upper Arm in the segment name box. We'll define this using a proximal joint radius at the left shoulder joint center and make the radius left shoulder radius. We'll also use a distal joint radius at the left elbow joint center as left elbow radius. We'll use an extra target to define orientation at the lateral location using the left elbow and select left elbow, left shoulder, and left upper arm as our tracking targets. You can click Apply and Close tab before moving on to the right upper arm segment, which will be created by copying and reflecting the left upper arm segment. Now we can move on to creating the landmarks to define our forearm. Create a new landmark named left elbow joint center track and define it using an existing segment at the left upper arm. Use an axial offset of -1 and check offset by percent 1.0. We'll copy and reflect this to create the right elbow joint center, and we'll move on to creating the right forearm segment. In the Segments tab, enter left forearm in the segment name box and click Create. We'll define the segment using a proximal joint at the left elbow joint center and a radius of the left elbow radius. We'll use a distal joint at the left wrist joint center and a radius of left wrist radius. Add an extra target to define the orientation at the medial location using the left wrist marker, and use tracking targets, left elbow joint center track, left LFRA, LWRA, and LWRB. Build your model and copy and reflect it to create the right forearm segment. Now we can begin defining the landmarks to create our hand segment. Create a new landmark named left hand joint center and define this using the starting point at the left finger marker, ending at the left wrist marker, and using a lateral object at the left wrist joint center. Check offset using the following offsets and create a medial lateral offset at -1 times the left hand offset plus the marker radius. Check calibration only landmark and copy and reflect this landmark to create the right hand joint center. Now, in the Segments tab, we can create our left hand segment. Enter left hand in the segment name box and create segment. Define a proximal joint center at the left wrist joint center using a radius of left wrist radius, and a distal joint center at the left hand joint center using a radius of left hand offset. Add an extra target to define the orientation at the medial location using the left wrist B marker. Select tracking targets, left finger, and both of the left wrist markers. Click on Build Model and close tab before proceeding. You'll notice that the new hand segment looks a little small compared to the rest of the skeleton. We'll want to scale this to 125 in all directions to make it look a bit more anatomically correct. Now, you can copy and reflect your left hand segment to create the right hand segment.